It's one thing if we can find the area between two curves, if we're already given two limits of integration for x equals a to x equals b. However, the real challenge is most of the time is finding the area between two intersecting curves. And of course, to find the area between two intersecting curves, we have to find out where the two curves intersect, because those values will give us our limits on integration right here. And we might kind of have an idea right here looking at this graph of where these might be right here. We've got the curve f of x equals 4 minus x squared. That's our top curve here in red. And we have the curve g of x equaling y equals 3x. And we might have an idea of where these coordinate points might be, but if we don't have a graph, how do we do it? Well, of course, that what we have to do is that we have to set the two functions equal to each other. So we want to find out, where does f of x actually equal the curve g of x to do this sort of situation, because it might not always be obvious from the curve where those points are if we're even given a curve in the first place. All right, so what do we do? Well, let's set them equal to each other. We've got 4 minus x squared is equal to 3x. I like my quadratic equations to start with a positive x squared because I'm a positive kind of person. So that means I'm going to add my x squared and subtract my 4 over to the other side of this equation, give me an equation that looks like x squared plus 3x minus 4 is equal to 0. If you remember, anytime you solve an equation, a polynomial equation with a degree higher than 1, you set the equation to 0 and you see if you can work it by factoring first of all. And of course, this one does factor directly. We would note that if we were to factor our two values for x squared times x is x squared, and the factors of negative 4, which add up to positive 3, which would be positive 4 and negative 1, we get the factors x plus 4 and x minus 1, which means that we have two solutions here, x equals negative 4 and x equals 1 as our points of intersection right here. We see we're at x equals negative 4 down here. If we follow the line down, we can actually find the y value that goes with it. And we go all the way up to x equals 1 to find that coordinate point here. Now, we're not really so much concerned with the x and y values for both of those points, just the x values, because these two numbers now become my limits of integration, my lower and upper limits of integration. So I'm going to use these to help me find my area between the two curves. All right, so what should we do? We're going to take the upper curve. In this case, that's f of x, we can see from the graph. So we're going to take our integral from negative 4 to positive 1. We're going to take our curve 4 minus x squared. We're going to subtract 3x. And of course, all of this is with respect to x dx right here. So we're going to take that integral right here, a little bit of rearrangement. I like, again, putting things in order just because, I don't know, it's sort of my own personal OCD about these sorts of things. So I've got 4 minus 3x minus x squared dx. Of course, my pen doesn't like my OCD, doesn't like things neat and orderly. Oh well. So we've got 4 minus 3x minus, that's supposed to be a minus x squared. When we take the antiderivative, we evaluate 4x. Minus, let's see, integrating right here, this is 3 halves of x squared minus 1/3 x cubed. There's nothing like nice numbers like these to deal with. So we're going to go from negative 4 to positive 1 in this evaluation. Well, okay, we're going to substitute in our numbers. So on the one hand, we're going to have 4 times 1 minus 3/2 times 1 squared minus 1/3 of 1 cubed. That's just 1. And we're going to subtract from that the quantity, 4 times negative 4 minus 3/2 of the square of negative 4 minus 1/3 of the cube of negative 4. Let's see what we can do to fix some of these things right here. Okay, so carrying out some of the algebra that's required right here, let's take this to be, of course, 4 minus 3/2 minus 1/3. And we're going to subtract away from that negative 16 minus 24 plus 64 thirds here. Okay, and holding with our fancy arithmetic right here, the common denominator of these three fractions right here, 4 over 1 3/2 and 1/3, is 6, so that's going to give us 13 over 6. And we're going to subtract from that, let's see, we're going to take negative 16, negative 24 plus 64 thirds, and that's going to give us negative 56 over 3. So negative 56 over 3, and of course getting the common denominator and adding the like terms is going to give me a total of 125 sixths. And that would be the area enclosed by these two regions. And we're done with this problem.